Warm welcome you all to channel Meet MIT, that is Math is Tricky. Warm welcome you all to channel Meet MIT, that is Math is Tricky. Thank you so much for watching my videos. Thank you so much for being with me. In this video, I'm going to solve some problems related to application of derivative. I'll be solving some problems related to rate measurement. Okay, let's start today's video with the first problem. The first problem is here. The side of a square is increasing at the rate of 5 cm per second of 5 cm per minute. At what rate the area is increasing when the side is 12 cm long? Okay, so first one problem. Here we are given, let's see here, if this is a square, then obviously if the square changes, its area will change. If you change the square, area is going to change. See here, R1, R2, R3. So you can see that area, it is being bigger and bigger. Okay, so area is changing. So now we are going to find at what rate this area is being changed. So it's very simple. Let here, let L be the length of the square with area A at any time t. Then we can write here, given here dl by dt equals here 5 cm per minute, and which change in length is here given 5 cm per second. We need to find dA by dt equals what when L is 12 cm. Okay, so it's very simple, as we have to find area, change in area, that means and at what rate the area is being changed. So we use it's for formula for area, so A equals L square. Formula for area of a square is here L square, so we can write here, let's differentiate with respect to time, so that we will be getting here dl square by dl into dl by dt, so that we can write here 2l into dl by dt is given 5, so we can write here 2 into l is also given 12 into 5, so it is here 120 cm square per minute. It means here the area will be increasing at the rate of 120 cm square per minute when the radius is 12 cm. Hope you understood this. It's very simple. First you write what is the given. Here I have just noted down the rate of change of length of this square sheet. Okay, now we have to find area of that square when the length is 12 cm. So let's write down the formula for area. Okay, it is L square. Now differentiate both sides with respect to t. So we'll get here 2l dl by dt, and then substitute the value to get the answer. Okay, so now move to question number 2. It's very simple. Just by practice you can solve the problem by yourself also. Question number 2, let's see here. A stone thrown a stone thrown into a font produces a circular ripple which expands from the point of impact. If the radius of ripple is increasing at the rate of 3.5 cm per second, how fast is the area growing when the radius is, again here, the let here R and A denote the radius and area of the circular ripple. Okay, at any time time t. Then let's write down what is the given. So we are given here 3.5 cm per second is dr by dt. Radius is here given 3.5 cm per second. How fast the area is growing? dA by dt we have to find equals what? When r is 15 cm. Okay, so as before we can write here simply dA by dt. A, let's write down the formula for A. d by dt is area of circle, it is pi r square. So we can write here simply pi is constant, so it is pi outside. Now dr square by dr, let's use chain rule, and then dr by dt, so that we are getting here pi means the simply can write 22 by 7. Derivative of r square is 2r. dr by dt is given here, you can see 3.5. So we can write now this, if we cancel here, so 0.5, so it is here just 122 into 0.5 into 2 into r is 15 here. So we can simply write here this is 1 and then 15 into 2, so 22 into 15, and answer will be simply here 30 and 30 and 3, 33, 330 cm square per second. Let r, s and b denote the radius, height and volume of the cylinder at any time t. Then we can write here 18 cm cube per minute, that is dv by dt is given 18 cm per minute. Okay, the volume is being changed at the rate of 18 cm cube per minute, and then also we have to find dh by dt equals what, and then radius is given r equals 15 cm. So let's use, as we are given here volume, we'll be using formula for volume. Also one thing we have to remember, in this case, that means in case of cylinder, see here only height will be changing, h will be changing with respect to time, and volume will be changing, but there will be no change in radius. This r is going to be constant, r will be same. So be careful and then use formula, and then we'll be getting answer. So let's start with the given one. We have here dv by dt equals d by dt is pi r square h, and then that is given to be 18. So let's differentiate this, so that we'll be getting here, it is here pi r square will be treated as constant and dh by dt, so that we'll be getting here dh by dt equals simply, it is here 18 by pi r square, and we can write here 18 by pi r square is, we are given here r square is, r is given to be here, sorry, it is here 8 cm, so 8 square, and it will be simply 8 by 64 pi, by cancelling we'll be getting a 2 9 32, so 9 by 32 pi, and here it is cm per minute. Okay, so it means that the height will be, the level of water will be rising at the rate of, at the speed of 9 by 32 pi. This is our final answer. Hope you understood this, and if you have any confusion, don't forget to share with me. Also, if you understand this, if you think it should be shared with your friends in your circle, please like and subscribe my channel. Question number 4. The problem is here. From a cylindrical drum containing oil and kept vertical, the oil is leaking, so that level of oil is decreasing at the rate of 2 cm per minute. If the radius and height of the drum are 10.5 and 40 cm respectively, find the rate at which volume of oil is decreasing. Okay, so question number 4. Let's solve this. Let here, let R, S and V denote the radius, height and volume of the cylindrical drum at any time t. Then we can write here, it is given here, it is decreasing. For decreasing, note down here, the level of oil is decreasing, is dH by dt will be minus 2 cm per minute. For decreasing, we are writing here minus. Okay, minus means it indicates the level is decreasing. Okay, so we need to find dv by dt equals what, when R is, it is given here 10.5 cm, height is 40 cm. Okay, so formula will be, we know that here dv by dt equals, simply we can write here d by dt and pi r square h. Now in case of cylinder, with respect to time, only height and volume will be changing, so this r and pi will be constant, so it is here simply pi r square dh by dt, which gives here pi means 22 by 7, r square is here 10.5 into 10.5 into dh by dt is here minus 2, which gives, if we simplify, we'll get here minus 693 cm cube per minute. That means decreasing, it is decreasing at the rate of 693 cm cube per minute. Okay, that means volume is decreasing at the rate of 693. Just to simplify, you'll be getting answer. So hope you understood this. What I did here, in case of cylinder, remember the cylinder, this is the shape of cylinder. If you see here, with respect to time, only height will be changing and volume will be changing. There will be no change in radius of this cylinder. Okay, so radius will be considered as constant. Pi is constant. So now differentiate and substitute the value of h, ds by dt. Okay, you may be confused, or you may have question why I have kept here minus sign, so that minus 2 will represent decrease in level of, so minus is here only to show the level is decreasing. Okay, so minus will be representing the decrease in volume or the level. So hope you understood this problem. Thank you so much. Number 5. Gasoline is pumped into a vertical cylindrical tank at the rate of 24 cm cube per minute, and the radius of the tank is 9 cm. Then how fast is the surface rising? We have to find how fast is the surface rising if dv by dt is given. So very simple. Question number 5. So let's write here, let R, we are talking about cylindrical tank. So R, S and V denote the radius, height and volume of the cylindrical tank. Okay, so cylindrical tank we are given here. Then we can write at any time t. Then what we are given here, this is 24, no doubt please, 24 cm cube per minute. That means dv by dt is here 24 cm cube per minute. Okay, now we need to find dh by dt equals what when radius is 9 cm. So let's start with the given one of we have v is v equals pi r square, yes, and then dv by dt will be pi r square dh by dt, which gives here 24 equals pi r square is 81 into dh by dt. So if we cut this, if we simplify this, it is here 8 and 27. It means here dh by dt will be 8 by 27 pi. It means here it will be changing here. The rate will be 8 by 27 pi. It is here cm per minute. It means the level will be the surface will be rising at the rate of 8 by 27 pi. This is our answer. Hope you understood this. If you have any confusion, you can ask me. You can write it in comment so that I can help you. And I don't think it's difficult. It is very easy to understand and then solve it by yourself also. You can do it by yourself. So just try to take the idea what is given and what is being changed with time. Okay. Question number 6. In this case, we are given here a spherical balloon is inflated at the rate of 18 cm cube per second. At what rate the radius is increasing when the radius is 8 cm. So here, let as before we can suppose here R and V denote the radius and volume of spherical balloon then at any time, mention the time, at any time t. Then we can write here a spherical balloon is inflated. What is the given here? Cm cube per second means dv by dt is given here. Dv by dt is 18 cm cube per second. We have to find dr by radius is increases. Dr by dt equals what when r equals 8 cm. Okay, so we can start like this. V equals 4 by 3. Remember the formula pi r cube, and it gets here dv by dt equals, just differentiate this 4 by 3, pi is constant, and differentiating this with respect to first r, dr cube by dr into dr by dt. So we are given here 18 equals 4 by 3 pi, it is 3 r square, 3 and 3 cancels, r square and r dash. This is what we are going to find. So it will be giving here, if you simplify 4, so 4 to the 9 times means 9 equals 2 pi and r square is 64 r dash, that means dr by dt will be simply here. So 128 by 9 by 128 pi. This is what that means, 9 by 128 pi cm per second. This is the rate for the radius. That means radius is increasing at the rate of 9 by 128 pi. Hope you understood it. It's very simple. In case of a spherical balloon, the formula is 4 by 3 pi r cube for the balloon. And then how to differentiate, you know, first you differentiate with respect to r and then r with respect to t. So that you'll be getting encouraging me. Thank you so much for liking and subscribing my channel. And if you have not subscribed my channel, please subscribe it and share among your friends also. Also hit the bell icon so that you will be getting notification as soon as I upload the video. Okay, so let's continue. Question number 7. Question number 7 is like this. The radius of a conical tank is 1 by 3 of its height. Water flows into a inverted conical tank at the rate of 4.4 cm3 per second. How fast is the level rising when the height of water is 3.5 cm? Okay, so for this, let's here it is about conical tank. So let R, H and P denote the radius, height and volume of conical tank at any time t. Then see here, this is 4.4, then dv by dt is given here 4.4 cm3 per second. Also we are given here height of this water is here, h equals given 3.5 cm. Then we have to find how fast is the level rising, means dh by dt equals what? This is what we have to find. So let's use the formula. We have p equals what? 1 by 3 pi r square h. So 1 by 3 pi r means here we are given the radius is 1/3 of the height, means r equals h by 3 is given. So we can use here r square will be h square by 9 into h. It gives here pi h cube by 27. Then dv by dt will be how much here? So it will be 3 pi h square and dh by dt into 27. So it is here 9. It gives how much? Pi means 22 by 7 into h square, means h is given how much here? We can say 3.5. So 3.5 into 3.5 by 9. Okay, so we can cut this 0.5. Also dv by dt is given 4.4. 4.4 equals to 22 into 0.5 into 3.5 by 9. So this point, and we can cut here this point, and this also cancel. So it is here 2 times 22 into 2 is 44. So we can write like this. This is cancelled, then it will be 5 10 here. So 5 to the 10, and simply we'll be getting here or 4 into 9 equals h dash 335 dh by dt. So it will be simply ds by dt will be how much? 36 by 35. This is the rate, that means the height will be changing at the rate of 36 by 35 cm per second. Okay, 36 by 35 is the rate at which height of the water is increasing. Okay, the height of the water will be increasing, or it is rising at the rate of 36 by 35. Now let's move to another question. Question number 8. Question number 8 is here. Question number 8. Let me solve it for you. A spherical ball of salt is dissolving in water in such a way that the volume is decrease of volume is proportional to its surface. Remember, surface means total surface. So we are talking about a spherical ball. So let R, S and V denote the radius, surface and volume of a spherical ball of salt at any time t. Then what we can write here? Volume is decreasing at the rate of dv by dt is proportional to minus. Yes, minus means decrease. Okay, so minus indicates decrease in volume. Okay, we can write here dv by dt equals some constant times, yes, k is constant. Now use the formula. So d by dt of volume of sphere. Okay, so 4 by 3 pi r cube equals minus k into 4 pi r square, that is the surface area. So if you differentiate this, you will be getting here 4 pi by 3 r square into dr by dt equals 4 pi r square. 4 pi r square, you can check here, this 4 pi r square cancel. So dr by dt is simply here times k minus k. It means here minus means decreasing, that means radius is decreasing at constant rate. This is what we have to prove. Okay, so hope you understood. If you have any confusion, please share with me so that I can help you. I'm always there to help you all. Okay, my all the videos are for you all, to benefit or to support you to excel your mathematics. Please, you feel good and share your feelings. Thank you so much. God bless you. Thank you so much. God bless you all.
Thank you so much for watching my video. I hope you like this video. Please do share this video with your friends, in your circle, in your social media, and please don't forget to subscribe my channel. Thank you so much. God bless you.